Hello, welcome back. So here is the here is a session that I have opened for the test run I did with 50 users, right? And by default, you see couple of graphs like this. This is what load runner gives you by default. The default graphs, even though they give, it may not be this is what you want. All right, and here is my default. The way that I approach that I first figure out if I have how is my virtual user stats, right? That means this graphs is going to tell me more or less that if the test ran fine or not, right? So for example, if the virtual users are stopping in the middle of the test, let's say you start with 50 users, then maybe say after 5 minutes you just only run 40 users, 10 users stopped, right? Then you cannot really claim the result for a 50 user test that you plan to start, right? Or else, so that is why the first thing that I check, if the users are running fine or not. So the two statistics, two graphs that can give me virtual user versus elapsed time, and let me show you how to get that. And I think by default, load runner load runner has already given you that graph. Okay, so you need to, this is my fast graph. Okay, so this is going to tell me that we are looks like things are okay, right? See, all 50 users are running for a good steady state time. Okay, and also I can add one more graph. Let's add new item, add new graph. So look at the virtual users, and then I think let's go to the virtual user summary. Okay, and see what's going on there. So this is going to give me a good summary that okay, all 50 users are actually running fine. Okay, let's drag this thing and drop it just after the running virtual users. Okay, so with running virtual users and virtual user summary, it gives me a good idea, good confidence that test ran fine. Okay, so after that, what I'm going to do, I'm going to get bunch of data points based on the response time analysis. Okay, so first thing that I'm going to do, I'm going to get the average response time. So let me go here. Average response time is already given there by default, so let's pull this graph and put it on top. Okay, so this is average response time, and then what I need to know, what is the transaction distribution. Okay, and this is already there. The transaction summary is going to give me what are the distribution for the transaction. So let's grab this thing and put it here. Okay, and further there are more graphs, like as I told you that average response time is not going to tell me everything about the transaction, and I need to get 90th or nth percentile time. Okay, so that graph is not available by default. So let's get that graph, add new item, add new graph, and percentile response time would be available in the transaction head. Okay, and as you see, this is the transaction response time, percentile response time. Let's open this graph. So the graph has opened, and this is how your transaction response time shows. And if you want to find out what is the 90th percentile response time, you just go here and check it out, what is the 90th percentile time. If you want to get 99 percentile time, you can get it here. So all those things whatever we discussed in the percentile response time, those things are plotted on all the data that what you have collected for this test in this graph. Okay, and also I like to know how the transaction distribution. Okay, so basically, for example, this graph, this graphs give me the summary, but I would like to know if lessons happening uniformly or not. That I don't have any idea. Okay, and at this time, just what I'm saying is that okay, there are 166 transactions happened. Okay, and by looking at this graph, this says that yeah, these things happened, because they have collected a lesson at different time, but I would like to know how many, right? So basically it has given me at this time the transaction response time for lessons is 9.948, but I do not know how many transactions occurred at that time. Okay, so to know that, let's go to new item, add new graph, go to transaction, and let's go to transactions per second. Okay, so now this is going to give you a fairly good idea, for example, there are 0.297 transaction happen. You cannot have actually 0.297. The reason is that the granularity, because they have averaged over 64 second. To see the real data, so let's change this to say 1 second for every second. Let's see what's the data. See for example, at this time I have 4 transaction. Okay, and then when I make it granularity to 40, 62 second, then it's going to average out 62 second and get a data point. Okay, so essentially what I'm saying is that this data point and 64 second at a time, that data point is just same. Okay, and it may happen that sometimes whenever you have a lot of data points, it may not, it's a good idea to plot with a granularity. Okay, so let's get this thing up. Okay, so with this, let's make it to 5 second granularity, so that would be even better. Okay, so it's a 5 second granularity, so this is the result that I saw. Okay, and now we have done with the transaction analysis. Okay, so all those things, like basically looking at these graphs, okay, we just say that your test is running fine, or if your whatever the performance acceptance criteria we discuss is met or not. Okay, so these are two things, and next thing is that I'm going to do about system statistics. Like, just want to know, like, the system under test, whatever I'm running, how does it behave, and also the load generators. In this particular test, my system under test and my load generators are on the same machine. So therefore, even though I have collected data, they may not be very realistic. In fact, in the real time, you run with the load generators and system under test, they are completely different. Even the system under test may have multiples of machines. Okay, so in that case, while you design the scenario, ensure that you monitor all those machines that is part of the system under test, including the load generators. So once you monitor those things, then you must have collected data, and what you're going to do here is going to plot those data in this analysis session. So let's do that. Graph, add item, our new graph. So here you need to go to system resources, and I have already, because the local host that I have run my test are Windows, so therefore it's showing Windows resources. And notice that I have configured, when I run this thing, when I was running the scenario, I would have configured here in the Windows resources all these things. Since I have configured all those things, so therefore controller collected data, and now I can analyze. So this is the Windows resource, and if you open it, sorry, if you open graphs, then you're going to see all those Windows resources. Notice I don't really need, because this, it has collected so many data that I am not really cannot make it out what is going on here. So what I need to do, I need to monitor couple of things. I need to monitor the CPU utilization, the available memory, okay, and something related to network and all this thing. And these three statistics are going to give me a fairly good idea of what is happening in the system. And if I want to monitor really, like say for example Oracle database, then Oracle gives you additional plugins, additional stuff to monitor the database, okay, to so that we can later on analyze, like a report called AWR report. Okay, and similarly I think all these third party vendors, they all these software vendors, you know to diagnostic the system, they provides you all this kind of instrumentation which you can plug into load runner. So in this course we are not going to really dig deep into those things, but what you can do, if you when you start the test, if you take the AWR snapshot, and after the end of the test if you take another AWR snapshot, then you can compare later on what is happening. If the results whatever you're seeing in the response time, it is a correlating with something in the AWR report that you are seeing. So look, like a performance analysis is the, is a kind of a, like you need a holistic view. Okay, it's not that one thing is correct, it's always in performance analysis, it depends. Okay, and it's you need to really be a, like a good pair of eyes to figure out what is going on, and those things can, and more data you collect, probably more chances that you can get it. Okay, however, in this graph, I'm just kind of very confused. What I'm going to do, I'm going to, like, delete these graphs. So delete item. Okay, so all the Windows resources are deleted, so let's add new item, and here I'm going to do, let's go to system Windows, and here I'm going to filter and open, and I'm going to just go here and do only processor time. Okay, so now this is the Windows processor time. Let's rename it. Okay, CPU time. Okay, and looks like the system is okay, like only 30% is used, like we don't see any CPU bottleneck over here. Okay, and similarly I can add a memory. Similarly let's add available memory, and you see the memory starts maximum was 5 gigabyte, and then while the test is running, like as the basically as the time elapsed, more and more view user comes into picture, and you are seeing that the memory is decreasing. Okay, and notice that here it says 43, but look at the scale here. Since it's 0.01, then you have to multiply it with 100. If you multiply it with 100, then you will see 4 GB. Okay, so it started with 5.3 GB and stops at something around 4.452 GB or something. Okay, so this is how you get those graphs. And then finally, this was a test that was running against a web server. Load runner captured other things, and the other things are stored in web resources. Okay, and then I need to know what is the throughput. Okay, and like HTTP status, responses per second. So those kind of things I say. So these things are going to give me. So these things are going to give me how the system, okay, how the when we are running the test, what kind of throughputs we are getting, okay, and what kind of HTTP responses we are getting. Okay, thank you.